HTTP is this wonderful protocol that is text-based, and it has this header that includes additional meta information about the request and the response that helps us, first of all, fetch the resource, but also then render or display it or save it as a file. So let's look at the headers and what they really contain. In the example that we saw earlier, this here is the request header. Now it starts with the request methods that we just covered. So we're saying that this is a GET request. We're getting, give me a resource, literally. And then we're specifying the resource location and then the protocol that we're expecting and using for this request, so that the server, when it's responding, can use and follow the same exact protocol. For example, if I was using a protocol that is not supported by the server, it could then respond with, hey, 400, bad request, I don't know what to do. So you see here, I used netcat, I sent get for this route, and then I said, I'm going to be speaking to you in HTTP version 2.8, which does not exist. So the Google decided to respond with HTTP 1.0, and then the 400 status code, which means a bad request. Let's look at some other important headers that are used in the response then. Let's go to the WP Shout website, and this the course landing page that we have here, that is the typical GET request as we discussed before. In here you will see that in the response, that is the HTML response here, but if we look at the headers exclusively, you'll see that there are a few interesting things. So we have the most important bit is the content type. So we're saying that this is going to be a text /HTML, so we're delivering an HTML page, and we're going to be using a character set UTF-8 encoded byte streams. Then we also add a date when this document was generated. So this is one of the first pieces that allows the browser potentially to cache this response, because it has a way to basically ask the server, hey, have you really modified this page, this resource, since this date? And then instead of responding with the 200, it can actually say, no, I have not modified, so the browser, and then when it says that not modified, it actually does not respond with the whole body, so that the browser can immediately reuse the cached version that it has. Another important bit here is the link. So this is a standard way for providing additional resources linked to this resource that are available for the browsers or other applications to use. And a good example of this is the alternative representations of this page. So as you can see here, this is a page ID of this, and there is also a JSON representation, type application JSON at this URL. So this is what I was talking about before. The same resource can have multiple representations. Technically, it could also be delivered over this same request URL just by specifying a different accept header from the browser. But in this case, to kind of simplify things and make more straightforward, we're actually utilizing a separate URL for this, which is the WP REST URL generated resource. Now, if we go to that resource, let's compare the response headers that we're getting back now. Let's go to the network tab and refresh this. And you can see here that this is still a GET request that we just made, but instead of responding with HTML content type, we are now responding with application JSON, right? So these are different formats. What other formats are there? RSS feeds. What are they? Those are XML, right? So we can say /feed. And then if we look at this, the first one is actually a redirect, because this site is enforcing the trailing slash. This is another good example that we can investigate, that this is a GET request and the response that we got is 301, which means moved permanently. And then there is the location that is provided with this. So here, further down here is the location, which is the same URL, but with just the / added. So that's what the browser did. It just went to that with the / added, and then we got back the content type with the success 200 response code and an application /RSS plus XML. Again, So this is a resource that has this content type. Now, an application such as the web browser, they're not really good at displaying this content type. So that's why for example, RSS reader does a better job. It knows how to interpret and parse this implementation. And similar to the DNS, where we had the TXT record, which accepts any arbitrary string that we can have some fun with, there is also the ability to add custom headers. So this is strictly really anything goes here. So as you can see here, Averti, the company running this site, has included a message that says, if you're reading this, you should visit and apply for the jobs and join and mention this header. I believe Automatic also does a similar thing. They have a similar header, but the idea here is that regular people are not going to be looking at this data. And if you are, then you probably have a reason for it, and you can use this as an opportunity to basically advertise. Sometimes you also get this in the actual HTML body, so I believe WP Shout does that as well. If we look at here in the response, it also says we're hiring. So if you're poking around and looking at these things, you can actually get some great ideas and like some hidden gems, and sometimes also Easter eggs and some fun little tidbits that are hidden under the source responses. Let's move on to the caching headers. So these are really important because browsers are built to save the resources. When it does not have to do the work, it will attempt to not do the work. Though in similar fashion as we as humans do that, browsers are not also willing to burn the network bandwidth and not reuse the resources if it can. So when we're getting a response like this, I am actually currently in the network panel here setting a flag that specifically sets the disable cache headers in the request. So if we want to see what that does, it does not impact the response header, it impacts the request header. And in the request header, we see the cache control. We're saying no cache. And that means we want a fresh response. It's like, no matter what you have in the cache server, please give me a fresh response. This is an ask. This is no obligation for the server to actually honor this. But typically, you're only sending this information when you truly need it. But this is a great function to know and to use when you really need a fresh response for the server, or at least for the server to kind of consider giving you a fresher response. Now, when that is being sent, then the response also includes, let's check it out here in the response headers, we are saying the cache control, this is public, max age, so how long can this response live? And then there is S max age at a super long time period. And these are very similar header string values, but one of them is intended for the middle proxies, basically in this case Cloudflare, that sits between me and the actual server. There's also Cloudflare sitting there, and that will be using this data that is also supplied by the origin server to say, okay, we actually can persist this in the Cloudflare's cache for this long in seconds. However, in the browser, please do not cache it because you requested that we are generating a fresh one for you. Now, if we look at another resource, such as a style sheet, for example, on here, you'll see that this is actually setting the cache control in the response header to a max age of very many seconds. And then it is also saying that this is when it was last modified, and this is when it expires. So instead of setting an age, you can also do an expires, and there's combinations of these that you can do in different scenarios. But the important bit here is that there's also the last modified and also the expires. So the last modified means that the client, in this case the browser, when it's reloading this page again, it can actually say, did this resource change? And if it did not, then it will reuse the cached version. So in this case, we have this resource here, and you can see that the browser actually did reuse it from the memory because all of these headers are very permissive in that regard, so it did not actually revalidate the timestamp, it just went ahead and did it. Now let's move on to HTTP response codes. So that's one of the most interesting things. We have a lot of them, turns out. So you've probably all heard and we've already mentioned the 200, right? That's a success code. Turns these are groups of response codes. So anything from 200 to basically 300 up until that, right, is successful responses. Then we have redirection messages. So this is a temporary redirect or this is a permanent redirect. Then we have client error responses. So that's a bit different than the server error responses because the client made a request for something that, for example, does not exist. So that's an error code 404, the very famous 404 page. And then the server error codes is when the client made a request, but the server could not complete it because it just, I don't know, went to sleep. If, for example, the PHP was not responding to the web server's request or anything like that. So a 500 response is also very typical that we see across the web. So let's look at how they look in terms of the headers that we're sending along with those response codes. We can again use a WordPress example here, and then I'm going to type in something that does not exist, and then we'll see that the get request got a 404 not found response. And then when that response is sent, then it also, in addition to that, we said, okay, that resource was not found, but we're going to give you this text HTML response so that you can render a nice response page like this. If we had not supplied this additional data and the actual body of HTML, the browser could just render the built-in error page that it has. But since we did supply the body, it could now render this page as if it was a regular page within the WordPress, but the status code means that neither the client is going to assume this is a good and intended response that we wanted, nor the Google search engine is not going to index this and think that this is something that the users ever want to find, right, through the search engines. So this is a typical 404 response code. Now, an additional one, an interesting one, is the redirect that we just saw in the list there. Now, if we go to this page, for example, here, notice that it has the trailing slash. Normally, WordPress has a canonical redirect in place that if you do have the trailing slash enabled for this resource, then it will actually redirect that request without it to have one in the end. Now, if I make that request, you noticed here the first response we got was to that GET request is moved permanently. And then within the response headers, we got a location. Where is that? Here is the location. So this is where the resource actually is. And then within the response, there was nothing. There was no body in it. So the header was sufficient to make the browser make the redirect. We looked at the successful response codes, right, for the 200s. Then we had a look at the redirection message. The client error response code was the 404. The 500 we cannot force from the outside really, but if you find it, if you see it online, you'll probably recognize it. And then we have the final set of response codes is the informational responses. And these are probably the least seen ones on the web. In reality, the most applicable might be the 100 continue. So that's a very simple one. It's used for larger uploads. We can send a request to the server saying, okay, we're going to be uploading to you. It's going to be this amount of bytes that we're going to be sending to basically validate whether they are going to be able to accept this. And then the server says, okay, HTTP 1.1, 100 continue. So they're basically ready to accept that request and confirm that they can process that amount of incoming bytes. So in this lesson, we've covered response codes that are being part of the HTTP responses. And then we also covered the HTTP methods. There are the primary ways to indicate to a server what type of deal we're now making, whether we're giving you the information or if we're requesting something from the server. These methods, these verbs allow us to communicate it clearly and nicely. And these are the fundamentals of the HTTP protocol, along with the HTTP headers that we covered as well. There are the request headers and also the response headers. that have all kinds of helpful information that the browsers can use to really efficiently and quickly deliver these resources to you in the form of quickly delivered websites or a video playback and things like that.